All right, so we're gonna start on this, and I apologize. I've been in like crazy mode trying to set up this pilot build. I'm GCing that on top of just meeting after meeting after meeting. A lot of what I'll start with is not going to surprise any of you. You're in the earth building world. We need lower carbon housing. We need affordable housing. So we started assessing what made the most sense to automate. It was Adobe largely for the material costs as compared to labor. So when you take the like percentage of labor to percentage of material, it has the best chance of return. Even if you fully automate stick build, everything in it, paint, the framing, insulating, the best you can do is about a 50% reduction. And that's because you start at 50% material cost. I've been kind of following Ben Alon's work out of off the East Coast for a while, so you can kind of go through what they're doing for tracking carbon materials. So we pulled some data from them, but yeah, life cycle is good. Recyclability, we pitched that a lot, and something that's been kind of exciting to the investors is that you can reuse these homes. They're not even generational; they're multi-generational. They're tens of generational. If you keep them dry, they're around for hundreds of years. This is kind of goes further into that graph. This is something we show investors. I don't tend to leave it in these sort of presentations, but given that we're nerding out and some of us are architects, I left it in here. And this gives you kind of like a rough breakdown of like your base level materials, your base level labor, and then the margins within those systems. I think this skews a little bit more fairly to Terran. This is probably honest, but it is somewhere in that realm. Even with the lightweight aggregates we deploy in our systems, you can still hit, $30, $50 a yard for materials. And this is like a real high level of how what we do works. We're actually on a new piece of equipment now. It's a much bigger version of the wire gantry you see in the center. This one was pretty slow. The new one's a lot faster, but the logic's very similar. It's 4 corner posts, 2 lines to each post. It does pick and place through vision, and then it does a tool swap. And that final tool you see on the right side, where it reads the topography of the wall, goes through and smooths it to a single plane. It does that on all sides of the wall, top, and then the 2 long sides, which is a fairly simple optimization problem, but that's like kind of that gives you the best sense of what we're pushing forward. The other big part of our research is in getting steel out of the system. And the first build, the pilot build we have achieved that working with Anthony Dente. We do that through a combination of design strategies, materials research, and reducing the weight of the mix. This is our drying chamber. I'm going to show you like a few like not super good shots from the lab, but this is just kind of the day-to-day. This is dehumidification chamber. We keep it at about 105, 108, which keeps us from having any sort of over baking results pushed into our numbers. Right now we've got about half-weight cob we've developed that's stronger than traditional cob, or at least to our traditional cob mixes. Everybody's doing their own thing, but very scientific about it. We track how much, to the pound of water, to the pound of clay. We take laser sieve analysis of the clay body, so we know what percentage of clay silt is in there through laser diffraction. And then we partner with Caboge in Europe, so we send out samples, 3 inches thick, 12 by 12, and they run R value. So we used to do the R value in-house. That's that machine on the left. It's a pretty rickety machine from China. It got us some approximate numbers, but we can never really like dial in. The machine on the right is actually quite great. The part that you see red there comes from a regional manufacturer. We designed it. That's our modulus of rupture, our MOR testing equipment. We do compression and modulus of rupture in-house, and we do as slow as possible to give us like the worst results possible. It's one of those things where it's like if you do better in your worst case scenario, it's just one more factor of safety over what you would need to deploy. So that the machine on the right there, and this is the lab dog. But everything on this rack here is either 4x4 or 4x8 inch compression blocks. You can see a row of 6x12 modulus of rupture blocks on the bottom, and then a couple few in the center there for R value testing. And we did get a high enough R value in our most recent testing round to be deployed in a performance review, at least to our climate and probably 1 or 2 zones above. And we can pull the structural steel out of the system up to seismic category C. So we are making like big movements in a deployable monolithic system. This is one of our first just sort of, we wanted to build something. You can see a strapping system on this. This is when we were still using steel. It's very difficult for our machine to work around steel in the center of the wall. I also have my own like reservations about it, but in this one we mocked up, it was for to test for a Habitat for Humanity build, which I'll show a shot of that later. They ultimately decided to stick build it, and then they ultimately weren't able to pull their permits. So that site has been undeveloped. So we might come back to it. It's 12-inch thick earthen vault on this one. I did put ribbing in it, although you don't have to. That was just, if I'm going to deploy earth in this strategy the first time, I want to be careful. We're now partnered with the city of Bloomington. So we offer accessory dwelling units that are already through code. And members of the community, given if they're in the right part of the town, can pick one of the designs and they are cleared to go. This is our current project. Actually, this drawing's very slightly out of date. But this wall here that curves around, I just set the rebar today for that, and I cut the foundation to pull in the electric and sewer. So we're like moving on that. I'm going to be building the bottom frame, the box below the earth, probably this weekend. It's pretty atypical to deploy earth over Western platform framing. We pulled permits to do that for the Habitat build. It's the first of that deployment I've seen. This structure has it as well. This was not meant to be built for about 2 years, so it's a little aggressive in some of the stuff that we've been planning, but because we lost the Habitat build, we decided to push this through because we wanted to build something with robotics this year. And here's just a more aesthetically friendly rendering of that structure. And I've even got like a sweet set of Victorian curved glass windows I picked up out of the basement in Louisville, Kentucky, like a decade ago that I'm finally going to get to deploy into something. This is the house we designed for Habitat. We're trying to be pretty subdued on this one, just a straight sort of 30, 40 footprint. And then instead of doing kind of the curved stuff that's been really pushed a lot with 3D printing, we took that one, like one slice off the front. I hope to do homes like this, but that one's on pause. Actually, the project owner for this particular build's on this call, I think. We are going to be doing a smaller version of this commercial structure. It'll be as a shop, hopefully in the spring, in the contract phase right now. So trying to push not only into residential, but commercial monolithic adobe. And this is a paper project. But this is the form that I'm most excited about. I think earth deployed in multifamily hits so many beautiful high points. Mainly that like there's not a lot of exterior wall due to the window loading, so you have a lot of protection. But then the party walls, the division walls, that are typically very expensive and have a lot of fireproofing and other requirements, are inherent to the material. The sound STC class of earth between party walls is better than double block, which is the standard. That's why it's nice to stay in like red roof inns. They look cheap. They're made fully out of block, but they're quiet. Cheap and quiet. This is a different sort of beautiful and quiet. And then I guess that's pretty sweet, but these are the sort of things like within your group of humans, we're going to be having an open house sometime probably 3rd week of October. If you'd like to see the equipment in action, it is going to be in Bloomington, Indiana. It's downtown. We wanted to go through building code and do everything just straight by the book for the first build. I don't know where this will put us in like as permitted structures. I think it'll be the first that's, like AI driven reinforcement learning. Probably one of the early monolithic adobe, but there must be a bunch of them in the Southwest. They're just not common where we're at. And something we've been trying to like back out just generally are estimates for adobe construction costs. I thought a few of you might have opinions on that. I've got pretty good numbers for 3D printed concrete because I got 4 estimates for my house. And then I've got like a good sense of like rammed earth and compressed earth block. If you know any developers, builders, investors, we love to meet those folks. We'd love to invite them out as well. And then I've been trying to do more presentations. My colleague does a lot of pitching. Our decks are largely for the investment world, but we're starting to put more and more together on architecture. And I'd like to pull a little bit more into engineering. At present, we still have like a few things that are in development where we haven't like figured out how they're going to work yet, so we don't present them. But we're getting there. We're getting closer to being able to say like, these are the systems that you could use to do X. X in our case is to build monolithic adobe walls that carry their own insulation that do not require steel or any secondary system for support. That's like out the gate. The first pilot will be of that nature. And then if you know anybody that wants a house, let us know. Try to give like the team at the end. This is more of the investor world, but you guys got kind of my shtick. So Zach's background is in AI. He's been in a series of startups. He's been passionate about doing low-cost housing for probably 15 years. We founded an eco-village together and rezoned property downtown Bloomington that has since been sold to like a local cooperative. Hey, Zuzu, come here. Little pink dog's barking. But that eco-village, we did the whole rezoning, and then we bought one of the factory farms Earthen compressed earth block machines for subsoil. So we've been like playing with this stuff for a long time. That particular machine didn't pan out, but the ones we're working on now, I think have a far better chance. This is a fuller team. You guys may, I mean, you know Anthony Dente, I imagine. You may know Steve Goodhue. He was in town for some of the Earth USA stuff this year. And then Raul, who's a developer down in the Austin area. And then Nick Eli is, you know, you're very, very lucky when you hire an engineer such as him as your first employee. And I put this on here just to help you all out. These folks recently gave us clearance in 20 or 21 states for Adobe financing. It's the only one I could find online. They were super easy to work with, and I just thought it'd be a resource you might be curious to have. So that's what I got for you on the front of like formal presentation. But I'd love to take questions and kind of talk through this world. They pull up this chat thing here.
Thank you so much for that, Daniel. One of the only questions coming so far through the chat is, where are you located? I read Bloomington, Indiana. Is that correct?
That is correct. Yeah. So we're headquartered here, and our first build is here.
Very good. Anybody else? If you have any questions, please drop those in the chat.
May I ask a live question?
Sure.
First of all, Daniel, I think this is fascinating. It's awesome what you're doing. Have you by any chance looked into IRA money, the Inflation Reduction Act? This seems like it'd be a perfect candidate.
No, I've not. Unfamiliar.
I would check it out because it's all about reducing carbon and creating jobs. And affordable housing. I would think they'd be all over it. You might need to go through your state, but yeah, check it out. It's the Federal Inflation Reduction Act.
Yeah, I was trying to pull up my notes there. Stop the screen share so I'm not jumping everywhere. IRA money. All right, I'll put that on the list.
I love what you're doing.
Oh, thank you. Sometimes I love it. Sometimes it's just blindly exhausting.
Daniel, this is Stephen. I want to thank you for the presentation, but also think what you said about having a good engineer like your first employee was probably one of the smartest things you might have could have done. I mean, I was looking at some of those sections and I was going, wow, I couldn't even imagine how that's going to work structurally. But, you know, you've got somebody on board letting you know everything you need to do, and at the same time minimizing steel. That's just phenomenal.
Well, to be clear, our first hire was a mechanical engineer who did robot design. we hired Anthony Dente and Verdant engineers for the first structural project. The pilot is designed by him, and we did that largely because we wanted to pull steel out of the system. And he's a conservative engineer, so if he figures it out, it's going to work. We have found that path. We found it for about 80% of the walls. There is one wall in the front we still have to do a small piece of shear wall in. It was a trade-off. It's kind of annoying, but engineers, if you give them really creative problems and some kind of leeway, they can usually back out an answer.
Yeah, absolutely. Thanks, Daniel.
Yeah, we are looking to hire a structural engineer in-house. We've been talking to a pretty big architectural firm about how we could partner with them to use our in-house structural engineers with their resources, which would give us reach in like 50 countries with engineers. So it's always trying to figure out who's excited to do what. I saw one question pop up.
Oh, gotcha. Yeah. Do you want to read those out, Daniel?
What type/size of projects do you anticipate partnering with developers on? Our sweet spot's like 10 to 100 homes a year. I tend to skew toward multifamily just as a form. I think it's better. I think it's a super appropriate deployment of Earth in particular. But that said, 10 to 100, the new machine, the reach of its build plate is such that doing multiple homes at a time is a lot more exciting to us. The R-value testing, they vary between like 0.4, 0.6 with like a pretty nice path to getting more than that. We had to run a performance evaluation on the current R value, and we did that with a performance review firm out of Indianapolis, and then we used the testing data from Caboge in Europe. And was it different? Yeah, it did vary from the in-house testing. We found that the gear we had just was super inconsistent. And we tried even testing controls like known plywood of R value 1.1, and we couldn't reproduce it. It was in the failure to reproduce a couple times that we decided to start shipping to Europe. It ended up being that it's $80 to send a sample to Caboge. It takes about a week. Takes them about a week to turn it around. And the cheapest we could do R value testing in the US on Earthen materials was somewhere at 400. And the most recent place we sent it never succeeded in testing it once. Largely because they couldn't plane a surface flat enough, but they were also experimenting with their own kind of like new tools. And I don't know, it's a hard material to test because the R value isn't super high in the best case scenario. But yeah, Caboge is great. You guys lean on them if you want to. They love it.
May I ask another question?
Sure.
So I'm not sure I totally understood from the photos, but it looks like you're putting in horizontal lifts and then the machine is compressing it in three dimensions or 3 directions. Is that correct?
That's correct. Yeah.
So how high are the lifts that you're doing?
So we don't have found our max lift height yet. It varies a little bit with regional soil, wetness of soil, and then weight of cob. Because we're a lighter weight mix, we conject that we can go higher lifts. And because we can work a little drier than is comfortable for human, like our shrinkage rates right now with our mixes are somewhere at like 1% when we were getting closer to 2.5, 3 when working by hand. So those things in aggregate mean we're probably going to shoot for something like, I always feel safe with 12-inch. I think we may be able to get to 18 or 20. That would be pretty nice. And there may be path beyond that too. It's all about that like slump rate at the bottom edge of the lift as you're going up. And then there are certain traditions in the Southwest where it's hot, where they're building in like 4-inch continuous lifts, just going around and around and around. It looks like more like 3D printing. So the lifts never really stop in that case. So, for us, we'll probably be deploying like a foot at a time this fall.
So when you say a lighter mix, that means heavy on straw?
We use lighter aggregates and maximum straw.
And
Yeah.
is the aggregate a proprietary ingredient, or can you talk to us about that?
Proprietary at present and also changing. So we're sort of like sorting out what
Fair
is
enough.
best. We've got an answer for the first house, and we're trying to develop something more for the second. But if you come out to the build site, it's like there's not that many secrets. You're going to see piles of stuff and be like, it's this stuff. But I wouldn't say like it's the stuff you should use yet.
I'm an old cobber I'm an old cobber who's mixed cob on tarps with, foot stomping. So I love seeing what you're doing with automating this.
Yeah, I've definitely done both. I've done more by hand than by machine, but we're getting close to making that different.
Cool.
And I think just to give you like some numbers, I think our most recent cob mixes are hitting somewhere in like the, we're less than 60 or 65 pounds. It'd be nice to hit something like, I think if you hit about 50, you'd be in like such a sweet R value that it would be a sort of a golden goose. We got a stack of questions here. Is it possible to your own heat box and study R values? Yes, that's what we had in there was the Chinese version of that. It had a box of foam around it. You absolutely can do that. We found it was a waste of time, given that we could waste of time and money, given that it's $80 to have it done in really high-end equipment. I think there are machines like 40 or 60K. So it's like, yes, you can do it. If you're partnering with Caboj, there really doesn't make sense to. And yes, the third-party certification in that case would be good. That was what we had to do, is even after we tested, we had to send it off to anyone. So we just skip that now. Sorry, I'm trying to, the questions are coming quick. I think I sent you how to do it some time ago yeah, you might have sent it to me. We've gone through a number of different options before we just start sending them off. Can you clarify the unit for the 65 or 50 pounds? So I consider a full weight cob. I peg it at 110. So we're talking 110 pound per cubic foot, and we're talking 65 pound per cubic foot or less in our mixes. What are you doing in lieu of steel? It's just design. We just lay the walls out in specific ways, and there's like, appropriate straw, appropriate mixes. Some of that stuff we'll be able to disclose a bit more information on soon, after we figure out how it works. Again, that kind of deal. But it's mostly just design work, and then working with the engineers and being like, what variables can you press, and can we, shift things to make it work? And then just a thumbs up there. Anybody else has verbal questions? I'm glad to go through those as well.
Hey, Danny, I got a question for you.
Yeah.
Hey, so you said that you are kind of in a currently the iteration of the machine is kind of bigger, badder. You want to speak to that at all? Can you tell us kind of what the iteration of the machines have looked like? Because originally we started with flying drones, and then we moved to the gantry, and I think we're on gantry 2.0.
Yeah.
Yeah, you want to speak to that?
Yeah, so we did start with drones. What really tanked that work wasn't, it was complex to anytime you're in flight. I still think in terms of elegance, that machine is probably the cheapest, and it's by far the lightest, and it's got the largest reach. But the FAA has incredibly strict rules once you hit 55 pounds, and we were having difficulty staying below 55 pounds and carrying material. It was easy to get the machine that could do it because it was tethered, plenty of lift, all that jazz. We switched to a wire gantry a little over a year ago. Wire gantries are the same thing you see at like the NFL for carrying the camera across the field. And we recently revamped our original wire gantry, and the new one that's coming together, I think we'll release videos of it in like 10 days, and it moves to the site in like 14 days. It's a very similar machine. It's similar to what you saw in the video. It looks a lot more sleek. It's far better waterproofing in the carriage. and then it's twice as strong and twice as fast. So the motors are just spec much larger. That's the main difference is speed and torque.
I don't know if you saw Loran asked a question. Daniel?
Yeah, I just saw it.
Okay,
We
good.
have a 3-person one. Can you talk more about the soil mix / content? How will building beyond Bloomington affect that? We test all the soil. Yeah, watch party. I got you from that. I do laser sieve analysis on every soil I use. We've just been partnered with IU's Geology Labs for that. We send the data off to Caboge and they kind of advise from there. That's not always necessary. There's tons of field tests you can do. And for the most part, if you got like a decent clay content and you don't have like expansive clay, you're going to be fine. When I was running across the Southwest with my wall sample and met up with a bunch of you, I think there were only 1 or 2 places I went where they said that the failure rate of the clay was 5% or something. So for the most part, anywhere that's got a decent clay soil, and we don't even have the best here. The particular build that we're doing now, that slide where I showed the drying dehumidification chamber, that included 5 compression, 5 modulus, R value, 5 mini compression, all the tests necessary to do code compliant building. And that was all of the soil off my property. So I dug the soil, I sent it to Laser Sieve Lab. They sent me the data. I sent that data to Caboge. They sent me a refined data about what it means for our build. And then I still go through the same process of testing everything. So I think you could skip most of those steps so long as you do the like prescribed test in the code. And then the soil mix, right now we run it like close to 2/3 aggregate, 1/3 soil. And then we follow Caboge's like numbers on straw. You can like grab any of their papers. They got like different opinions and different graphs and stuff. And we do it all in just like an electric mixer. So it's like kind of a really big version of the gas ones you can rent for mixing mortar. What prescribed field tests are you referring to? The field tests I think I don't prescribe those. Those are just like people try like the clay test where you roll your hand. I do the drop test a lot, like the ball test. Caboge has really refined some of those. Like they'll say, take a liter of slip and pour it from whatever, 10 centimeters. As it hits the ground, it should make a 7-centimeter circle. So you can get in some of their testing. I mostly use the lab side of things. So the compression, modulus of rupture. I don't always run the R value. I kind of just assume once we've pegged like a weight that it's probably going to be in that R value approximately. So I don't do that for every test. And then the only other one that's in code is the shrinkage test, which is like 4x4 by 3.5 by 3.5 box. It's 2 foot long, and it's got to shrink less than 2 inches, I believe. But all that's in the code. The field testing, yeah, I don't know. I do the simple ball test more than anything else if I'm just playing with a mix.
What kind of binder do you use?
Just the clay.
Thank you.
Yeah, so the clay on my site is at 22 or 23%, depending on where I dig from front to back. It's a little low. It gives our total mix somewhere in the like 7-8% clay range. It is nicer, kind of talking to your point on like places beyond Bloomington. Anywhere you get a higher clay content, I think you could probably start pushing like lighter mixes because you can use less of it. There's a lot of silk high clay, so that doesn't really do anything for the build system. It's sort of just a product that's in there and not yet typically useful. In fact, I would say it probably damages the strength of the wall ultimately. I think my phone went to sleep. You guys might have lost me.
Well, I think that what that probably means is people kind of run out of questions. We just need to kind of sit back and absorb what we just saw. But speaking for ECI, I think it's been a very worthwhile presentation and very inspirational. And what you're doing with it is really exciting. I can't wait to see what comes from that. I wish we could all run up to Bloomington and see see it all in person. But please keep in touch with us, Daniel, if you could. Would love to kind of come touch back with you sometime and see some of your successes and lessons, good and bad, if you don't mind.
Oh yeah, and to answer that last question there, definitely documenting. We'll probably put the same testing rig in the wall that Cabot did in Europe, so we can start doing parity testing. Moisture movement, heat movement through the walls, anything we can do data-wise, we will, that matches their research, just because it's nice to have parity when you're doing publication. And I'm like somewhat considering maybe going out there to teach some for their Earthen structures courses in spring of 25. So it's starting to like have those discussions. But we'll also do time lapse and video. We've got a couple media folks coming out. We'll probably hire some professional video as well. But yeah, if there's certain documentation you'd love to see, just let me know.
Okay, great. But it's awesome. It's amazing. So thanks and best of luck to you. Appreciate you coming on and sharing that with us.
Yeah.
I think that probably wraps things up for everyone. I would like to thank those of you who did come online and join us. And we are probably not going to be doing members present on a monthly basis, but when we do, we'll let you know as soon as we find out our next speaker. But you can pretty much count on us still being the first
Have a good
Tuesday of
night.
the month. So yeah, just everybody keep tuned in and contact me if you have any questions. And if you're not already a member, please sign up. We've got a way to do that on our website. And good to have you all along. Thank you very much for coming, everyone. Daniel, thanks again. We'll see you sometime
No
soon.
problem. Y'all have a good night.
Thank you all.